Assalamu alaikum. Now, dynamics. Up till now, we have studied the topic of mechanics, which is a branch of physics, that is kinematics. In kinematics, we worked out values of speed of a moving body, uniform or non-uniform speed and velocity. We discussed acceleration. We worked out the displacement of a body, final velocity, initial velocity, or the time taken to cover a particular distance. So these quantities were worked out, but we did not discuss about the main cause of these changes in the state of rest or of uniform motion in a straight line, like what causes the change in the direction of motion, what causes the change in the speed, or what brings the body to rest. All these things we studied without discussing the cause, main cause which causes the direction of a motion to be changed, the direction, beside direction the speed changes and all that. All the phenomena in which there is a change in state of rest of a body or a uniform motion of a body, a force is involved. The cause is the force. So kinematics, we don't talk about the forces. We simply calculate the variables like velocity, final, initial time, or acceleration, etc. But in dynamics, we study, this is also a branch of mechanics, and study the cause, that is the force, which is responsible for bringing a body to rest, or which causes a body to start its motion, change in direction, etc. So we'll begin our dynamics with the main part of this field, that is Newton's laws. Newton, you know the name of the scientist, so he gave three famous laws regarding the motion of the bodies. There are other laws also given by Newton's, but in this dynamics chapter, we will begin with the three basic laws. And first law, which is also known as law of inertia, and second law is famous as F is equal to ma, and third law is famous as action reaction. So first we will study the statement of the law, then we will discuss each law in detail separately. So of course it is easy to memorize the Newton's laws, but of course it is more important to understand them. People know what the laws say, but some of the people, they do not know that what do they mean. Now here I am giving the statements of all three laws. So first law, what it says: an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. Okay, so here unbalanced force, the force which is the resultant force. Suppose a forward force is 10 Newton and at the same on a body, and no backward force is acting on the body. So it means this is only the resultant force or unbalanced force, and which may accelerate the body. Okay, and in the same way, if forward force is 10 Newton and backward force is also 10 Newton, means there is no unbalanced force on the body. So body will continue moving at a constant velocity if it is already in motion, or it will stay at rest if it is already at rest. So, and if forward force is 10 and backward force is 4, means we will take the difference. 10 minus 4 is 6 Newton. So the unbalanced force which will be acting on the body is 6 Newton. Okay. We will have more detail later on. Let's see what second law says. It is, the simple statement is what? F is equal to mass into acceleration. F is equal to ma. And the third law, for every action there is an equal and opposite reaction. Now, first law is also called law of inertia, because an object will resist the change in its state of rest or of uniform motion, depending on how much massive it is. Massive bodies, they resist more they resist more to the change. Okay, so an object will stay at rest, and an object will stay in motion at a constant velocity unless acted upon by an unbalanced force. So Here, first law, once airborne until acted on by unbalanced forces like gravity or air or fluid friction, it would never stop. Okay, once the ball or shuttlecock is thrown, it will continue moving until unless any force changes its state, like gravity will pull it down, so it will fall downwards. Otherwise, if there is no gravitational force acting on this ball, or no air resistance, then it will continue moving in that line in which it was thrown. So it means these unbalanced forces, gravity and air friction, etc. Here, because this is moving in air in the video, so in it will continue its motions. Gravity will pull it downward, so that will follow a curved path, or it will never stop if there is no unbalanced force acting on this. Okay, so this is the golf ball, and it would remain there on this until unless it is being hit by the cue of this uh, golfer. Okay, until unless it is hit by the golfer, it will remain at rest. Why then do we observe every object in motion slowing down and becoming motionless seemingly without an outside force? It is a force we sometimes cannot see. Okay, that is the friction. Like suppose you see the ball rolling. So why it stops? Even if the floor is very smooth, there will be some friction. That is the sliding, the force which acts between the two bodies which slide against each other. So that brings the body to rest. Apparently, we don't see any force, but that hidden force is friction, which acts on that rolling ball, objects which being dragged. In the same way, air friction or air drag is also that kind of force which act on the bodies which fall through the air or they move through the air. Okay, so in the same way, like chairs and objects on the earth, we feel that there is no force on them, but there is a force. Okay, and that force again may be the gravity or maybe the friction. Objects on earth, unlike frictionless space, the moon travels through or under the influence of the friction. Okay, on moon of course there is no friction acting, but there is some other force which causes this revolution of that moon around the earth. In the same way, there is an external force, unbalanced force, which causes earth to revolve around the sun. So friction, there are different types of friction here. You simply, in your grade, you simply need to know the sliding friction and fluid friction, air or liquid, okay, which acts on the bodies which fall through the air or liquid. Like if you drop some marbles through the fluid, so that will slow down because of the this will speed up because of the gravity, but it will slow down an upward force of fluid friction acting on it. In the same way, sliding friction or rolling friction, that will be acting in the opposite direction to that of the motion. So slide a book across a table and watch it slide to a rest position. Of course, it will stop. If there is no friction, it will continue sliding on that table. Okay, so the book comes to rest because of the presence of a force. That force being the force of friction, which brings the book to a rest position. So every sliding object will come to rest, no matter how much greater force you have applied to push it. Okay, but finally the friction will overcome and it will bring the body to rest. In the absence of force of friction, the book would continue in motion with the same speed and direction forever. Okay, or at least the end of the table is reached. Now let's see Newton's first law. Of course, we have to wear a seat belt when we drive. Okay, we should not be like this person who is not wearing the seat belt and Due to this accident, he is thrown forward. Okay, why he is thrown forward? Because every object continues its state of rest or of uniform motion in a straight line. A book at rest will continue at rest until unless it is uh, lifted up by a person, or it is pushed or pulled by a person. In the same way, a person who is driving at a constant speed, uh, uh, the body is in motion. When the car hits the wall, car comes to rest. Okay, so will remain at rest until unless no external force act on it. In the same way, a car moving will come to rest. The person who was in motion, the upper part, it tends to continue its motion in a straight line, and due to that inertia, he is thrown forward at that same speed with which the car was traveling before hitting the wall. Okay, so that means here 80 meters, kilometers per hour. Second law, very famous. F is equal to ma. Here A is acceleration, m is the mass of the body, and F is an unbalanced force. What does the statement say? The net force of an object is equal to the product of its mass and acceleration, or F is equal to ma. Okay, so let us go back and discuss a little more. F is equal to ma means like whenever any unbalanced force acts on the body, it produces an acceleration in the body, and the magnitude of that acceleration is directly proportional to the force applied, provided mass remains constant. The greater the force, the greater will be the acceleration. Okay, and the smaller the force, the smaller will be the acceleration. So it means F is equal to ma, and if mass is not changed, the increasing the force will produce greater acceleration. In the same way, if you want to produce same acceleration on a body, on bodies of different masses, suppose 1 kilogram body of mass 1 kilogram, and 1 newton force will accelerate it by 1 meter per second square. So if you want to keep the acceleration constant and the body of mass is 2 kilogram, then you need to increase the force, and in the same way, that is 2 newton, and for a body of mass 3 kilogram, to produce an acceleration of 1 meter per second square, you have to apply force of 3 newton. So it means F is also directly proportional to m, provided A remains constant. Okay, now here when a mass is in kilogram and acceleration is meter per second, meter per second square, so the unit force is newton. 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second, or 1 meter per second square. Okay, so here you have to solve this question. How much force is needed to accelerate 1400 kilogram of car 2 meter per second? You have to calculate the acceleration formula. F is equal to ma, and you have to fill in the numbers in this formula. 1400 kilogram into 2, so the force is 2800 kilogram into meter per second per second. It means 2800 newton. Now here are some you can say spaces to be filled in. So if mass remains constant, doubling the acceleration doubles the force. If force remains constant, doubling the mass will halve the acceleration. If you don't increase the force and keep this force same and keep on increasing mass, so it means acceleration will not increase, it will decrease. Let us see here, 10 newton force, mass is 2 kilogram, so acceleration is 10 divided by 2, F is equal to ma, A is equal to F upon m. 10 divided by 2 is 5. Okay, so 20 newton force, of course, the acceleration is doubled. Now force is same, but acceleration has become less. It means mass has been changed. Okay, so how much acceleration mass will be there? So F is equal to ma, m is equal to F over A. So here the mass, it means it is 4 kilograms. So 20 Newton force could not accelerate mass of 4 kilogram at 10 meter per second. Okay, so since the mass was doubled, so 20 Newton force could accelerate it by only 5 meter per second square. And what happens when the force is 10 Newton and mass is 5 kilogram? So acceleration will be only 2. Okay, and this part is left for you. Okay, now Newton's second law proves the different masses accelerate to the Earth at the same rate, but which with the different forces. Okay, so all the bodies which fall under the gravity, they experience same accelerating force. Okay, the acceleration is same, but the force will be different because force again depends on the masses. 10 kilogram mass, so how much force is needed to produce, suppose 10 Newton is its weight, W is equal to mg. So 10 Newton downward force is producing acceleration. This rock is falling due to its own weight. So A is equal to 98 upon mass is 10 kilogram. So answer is 9.8 meter per second square. Another mass which is very small, that is only 1 kilogram, that will also experience same acceleration because the force will be smaller on it. Okay, the force acting on this body will be simply 10 Newton if you round it off. Otherwise, exact value is 9.8. 9.8 is always almost equal to 10. So 10 upon 1 is 10 meter per second square. Both bodies will have the same acceleration. Okay, so different masses accelerate to the ground at the same rate. So the force which will be acting will be different. Greater mass, greater weight, greater gravitational force. Now you have to check your understanding. Here are some questions. What acceleration will result when a 10 Newton, 12 Newton net force applied to a 3 kilogram object? Okay, or a 6 kilogram object. Two objects are there of different masses. How much acceleration will be there? Second question. Net force of 16 Newton. Acceleration produced is 5 meter per second square. You have to determine the mass. How much force is needed to accelerate a 66 kilogram square to 1 meter per second square? Okay, what is the force on 1000 kilogram elevator that is falling freely at this acceleration of 9.8 meter per second square? 9.8, you can round it off and you can take 10. Again, there are a few things to check the understanding, and there are, I think, answers also given, so you solve it later. Now there are types of forces: the gravity, which will cause bodies to fall towards it. Moon revolves around the earth because of the gravitational force. And electrostatic force is the force of attraction or repulsion between the charges. Magnetic force is the force of attraction and repulsion between two like or unlike poles. Okay, gravity is only attractive force, but electrostatic force and magnetic force may be attractive or repulsive. Okay, depending on what type of charges are there and what type of force face each other. Friction, which slows down the moving object and tends to bring them to rest. Now, third law. For every action, there is an equal and opposite reaction. The famous law here, according to Newton, whenever object A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force. Okay, you will be exerting downward force on the chair. So at the same time, this chair will exert an upward force on your body. Okay, the magnitude of the two forces will be equal, but the direction will be opposite. Okay, so the two forces resulting from this interaction, of force on chair and a force on your body, these two forces are called action and reaction. Any of the force can be called as action and any can be called as reaction. Okay, one is action, the other one is reaction. This computer is it's applying force on the table. Table is applying force on this computer also. There are some other example from the daily life. See, this is the fish. So it swims due to the propulsion of this water. Okay, it propels water in the backward direction, it uses its fins, and as a result water applies forward force on it and it moves forward inward. The size of the forces on the water is equal to the size of the force on the fish. These two forces are in the opposite direction but in the have the same magnitude. Okay, fish applies force on water in the backward direction, and at the same time water applies force on the fish in the forward direction, causing it to swim. And bird flying gracefully through the air. Birds. This is depends upon, again, this depending on the Newton's third law of motion. It pushes the air down on the like it pushes down on the air with the wings. The air pushes their wings up and gives them a lift. So lift force here it is caused. It pushes the air down, so that push force is acting downward, and the lift force acts upwards. That is why it remains at a height. Okay, here action reaction are involved regarding the height of this flying bird above the surface of the earth. Why it remains at a height, why aeroplane remains at a height, that is also because of the lift force. So again we are considering that flying motion of the bird flies by use of its wing. So it pushes the air downwards and air provides the upward lift force. Okay, and these two forces, upward and downward forces, are of equal in size and opposite in direction. Other examples here, the baseball forces the bat to the left, and this is an action. The bat forces the ball to the right. Okay, they interact at the same time. Okay, they apply force in the opposite direction. The magnitude of the force will be same. Suppose the ball applies 10 Newton force on the bat, so bat also applies 10 Newton force on the ball in the opposite direction. And motion of the car on the way to school. The car is equipped with wheels, and wheels will apply backward push on the road, and they grip the road, and the road is pushed backward, and as a result the road applies forward force on the wheels. And action reaction of the rocket, that is also a very famous example. Third law of motion, various fuels are burned and the exhaust gases are produced. Okay, these hot gases are pushed downward. So push of the rocket on the gases will cause a reaction force on the rocket by those exhaust gases. Okay, they push against inside the tube of the rocket and escape out of the bottom of the tube where they are present. So the gases move downward and the rocket moves in the opposite direction. Another example is the firing of the bullet. Okay, that when you fire a bullet using a gun, so gun applies a forward force on the bullet. So bullet moves at a greater velocity, and there is a spring which will cause the bullet to get speed. Okay, so a spring inside the gun will stretch and it will push the bullet forward, and at the same time backward force will be acting as a reaction on the gun which will cause the gun to move backward. So that is another example. But the speed gained by bullet is far more greater than the speed gained by gun in the backward direction, because this again forces are same but the masses are different. Bullet is too light, so that causes it to acquire greater speed. Okay, and the gun is very heavy. If suppose bullet is 200 gram, gun is 20 kilogram. So that same force which acts on both of them, it will produce a small acceleration in the gun in the backward direction. So here you have to remember these points. What are the point? Action and reaction forces act in pair, that is they act on two different bodies. Okay, they are of the same magnitude but act in opposite direction. They act at the same time. It won't happen that the second force, reaction force, will act later. No, they act at the same time. So they are different. Action reaction forces are different from forces in equilibrium which act on one body. If two forces acting on one body are equal in magnitude and opposite in direction, the body will retain its state of rest or of uniform motion. Okay, so it means equilibrium forces will not like they will cancel out the effect of each other because they are acting on the same body. But action reaction, the bodies are different. As we saw, bullet and gun, two bodies; chair and person, two bodies; water and fish, bird and air, and rocket and exhaust gases. So they are two bodies involved. One body applies force on first body, second body, first body applies force on the second body. So here there are example: action and reaction, two bodies involved. Okay, the boy is trying to reach the bank, so he applies backward force on the boat, and boat pushes him forward. So boat moves back and boy moves forward. At this point, the two forces will be acting, and these forces will be of same magnitude and opposite in direction. So here also action reaction forces same magnitude and opposite direction. So they do not cancel out each other because they act on two different bodies. So they may produce acceleration. See, boy accelerates forward and the boat moves backward. Okay, in the same way, a bullet moves forward, gun recoils backward. Rocket moves upward, the exhaust gases are pushed downwards. Are these two forces example of action and reaction forces? See what is written here. Book to table is applying an upward force on the book and weight of the book. What do you say? Since the two forces are acting on the same bodies, weight of the book is the force of gravity on the book. So force acting on the book. Table's force on the book, again force on the book. The magnitude of the two forces is same, direction is opposite. So these two are the example of action reaction forces. So now that is the end of the topic, and Allah Hafiz.